Okay, so we're going to pick up where we left off on the video from Monday, Tuesday. Okay, so we've talked about these things here. The second video, we talked about log versus natural log and finding the inverse of each. So we've done those two things. So now we're going to talk about these two things here. Properties of logarithms and change of base formula. So let me skip down to here. Logarithms, as I said, a log is just an exponent. So we can compare our properties of logarithms to our exponent laws. So for example, we have over here on the left hand side, we got x to the a power times x to the b power equals x to the a plus b. So I'm going to do a little example over here. I'm going to go 2 to the third power times 2 to the fifth power is equal to 2 to the eighth power. So logarithms, they represent an exponent. So I'm doing the same thing over here. I'm multiplying these two exponents together. So I can split them apart and go log of A plus log of B. So writing it in this format here. So looking at the next one, we have the division quotient property. So I'm going to write again, I'm going to go 3 to the fourth power over 3 to the sixth power. Okay. So I would rewrite that as 3 to the 4 minus 6. Okay. And then I would reduce that and say 3 to the negative 2 power. So when we have division, we subtract the exponents. So the same thing's happening over here. So here I have division, so I'm going to subtract my two logarithms. Okay, this property here is really, really important. This is the power to a power. So when I have, I'm going back to the first one, 2 to the third power raised to the fifth, this is the only time that I can multiply these together. So that would be 2 to the 15th. Okay, that property is really important in logarithms, especially when you move past Algebra 2, past your college algebra, into higher level math. So if you're going to go into like medical field or whatnot, you're going to need those higher level maths. And this property is really important. So what we have is our regular logarithm, or our log, which represents an exponent, raised to an exponent. So what we do is we just take our exponent and we pull it out in front. So we get this b times the log of a. Okay. Actually, I'm just going to leave that in there. So what we did in the next step is we pull the b out in front. Then we have this rule where x to the negative a can be written as 1 over x to the a. So we've seen this, back forever ago. If I go 2 to the negative 1 power, that's 1 over 2. So with logarithms, it's the same thing. So if you have the base and then you have the base raised to an exponent here, we could just take that exponent with the negative on that. And then here, the last one are anything to the 0 power is 1. So when we write it as a logarithm, you remember the 0 is the logarithm is equal to our exponent. So we have the log, whatever the base is, 1 is equal to 0. Okay. So what we're going to be asked to do here is to expand the logarithm. So I'm going to take it as it is and write it out in long ways. Okay. So what I'm doing is I'm taking this and writing it long like that. Okay. So I'll do this first example with you. So what we have here is the product rule. Excuse me. So we got a to the 6th times b to the 5th. So it's multiplication. So with multiplication, I add those logs together. So I'm going to start out with my first step. I'm going to go log. Notice that there's no base here. That means it's 10. But I don't have to write it. I can, but I don't have to. So I'm going to go a to the 6th plus log b to the 5th. Okay, now my next step is to go into this rule here, okay, because I have an exponent or a logarithm to a power. So I'm going to pull that power out in front. So I'm going to take this the 6 on the A out in front and the 5 on the B, pull it out in front. So my final answer is 6 times the log of A plus 5 times the log of B. So all we're doing here is kind of rewriting it longer. Okay, let's look at another. So this one we have the division. So I'm going to rewrite it, and I'm going to say log base 7, and that's to the power of 3. Both will be to the power of 3. So I'm going to go 2 to the power of 3 minus, because it's division, log base 7, 5, and then I have 3 to the power of 3. So I'm going to go ahead and multiply that out and say 9. Then I'm going to move on to my next step and pull my power out in front. So I have 3 log 7, 2 minus 9 log base 7 of 5. Okay. Now we could have pulled this out in front of here first and had the 3 and then a 3 here as well. And then when I moved on to the next step with the 5 to the power of 3, then that would have gotten me the 9. So either way that I had chosen to do it, whichever order, it would have ended up the same. Okay, let's look at 23. Okay, this one is also division. So I'm going to do it in the other order this time. So I'm going to pull my 2 out in front. So I'm going to go 2 log 6 of A over B to the third. Because as I said with the last example, it didn't matter which order I did this. Now I'm going to split this into this subtraction, the log A subtract log B. So I'm going to go 2, and I'm splitting it into 2 pieces. So I'm going to go log 6 of A minus log 6 of B to the third. Now I will distribute the 2 across, or I could go ahead and bring this out in front and then distribute the 2 across. I may do that. So we've got 2 log base 6 of A minus 3 log of 6 base of B. Log 6 of B. Now I'm going to distribute the 2 across. So I have 2 log base 6 of A minus 6 log base 6 of B. Okay. 24, we have cube root. So I want you to remember that cube root, I'm going to rewrite the original problem with an exponent. So I'm going to go x times y times z to the power of 1/3. So remember that index, this is called the index, can be written in the denominator of the exponent. So I'm going to expand this, and it's multiplication across these. So I'm going to do this similar to the last one. So I'm going to pull the 1/3 out here, and then I'm going to go log base 3 of x, and I'm going to go ahead and expand this and go log base 3 of y plus log base 3 of z. Now, one of the unique things that the ACT and Pearson, who does the exams, does is that they do this one here, times this logarithm, and then put 3 as the denominator. So it ends up looking final answer ends up looking like this. Log base 3 of x over 3 plus log base 3 of y over 3 plus log base 3 of z over 3.